and we're going to talk about robotic exploration.
You don't hear all those voices out there.
Is everyone? Alright, so we have a team beta, high school students composed of adults and mentors and students. We participate in the CT Electrothon race and FRC, which stands for First Robotics Challenge. We also run Tech Fest, which basically is a celebration of science and technology. We're always looking for new exhibitors if anyone's interested to display a wide variety of things. So,
and you're welcome to come. It's on June 1st, 2017. And we have flyers outside. Want to take one? So, what is a robot?
Hey, wait a minute. You guys also volunteer at Second Saturday Stars here at the high school every month, too.
Yes, and it's true.
Don't forget to add that to your resume. Thank you.
So what is a robot? By definition, a robot is a machine capable of completing a series of actions autonomously or semi-autonomous. And this is usually what people think when they hear the term robot. So some real robots that you may encounter are the Da Vinci surgical robot, which assists surgeons in doing surgery. The self-parking car, which many companies now produce. And robots can be as small and simple as a toaster and pencil sharpener to as complex as like our robot, which is outside, and manufacturing assembly arms, and can be as big as a space station. In terms of robotic exploration, there are many different types. One type is ground-based robots, and NASA usually keeps models of these robots on Earth to do that they send in space to just do tests to figure out if stuff will work or not on Earth. And telescopes are another major part of robotic exploration. Telescopes take programs and use sensors to move their motors to keep the telescope aligned at what you're imaging, because the Earth's orbit is moving during the night and the sky is changing. And one example is the telescope that's right over there in the dome. And a lot of observatories, they build high up in mountains, because as you get higher, the image is clearer because there's less atmosphere that causes a distortion in the coloring and image filtering of the image. And it's also above a lot of clouds, so you get more time to image. And since they're so high up, it's easier to just access them remotely. And one example is the Mount Lemmon Observatory in Arizona.
okay, so next up is our space telescope, the Hubble. It is fully automated and operated on Earth by humans. It is currently at the institution in Baltimore. While in space, being controlled. It has thrusters and gyroscopes to keep it stabilized. And can also do many of its tasks autonomously.
And we have an image, a 3D rendering of it. It's over there.
Also, there's Sputnik, which is the first satellite in space and uses sensors and power to keep it in orbit around the Earth.
It's no longer in orbit now.
Yeah, it's no longer in orbit.
It was one of the first.
And the third picture on the PowerPoint is the Skylab. A common misconception is that it's actually a space station that uses robotics to, help people inside it, when in reality it is a robot. It's a large-scale robot that people can actually live in and do many tasks. It is mostly completely autonomous and so the space shuttle. The space shuttle is the most complex machine humankind has ever actually built. It contains over 2.5 million moving parts within it, and can ground launch with a sequence of T-minus 30 seconds.
Well, the ground launch sequencer is basically it at T-minus 30 seconds, the human control of the space shuttle is completely cut off, and the space shuttle basically flies itself into space.
Yeah, so it's fully autonomous when it's flying itself, although there's sometimes human control. Yeah, humans basically just turn off engines. So it autonomously navigates into space, navigates its engine propulsion, gimbaling, controls, positioning of engines, and all that fun stuff. So yeah, the International Space Station also has gyroscopes to stabilize it. Like the Skylab, it is also a robot. It also has solar panels to that rotate to track the sun. And then Canadarm. It is basically a giant robotic arm that is used to maneuver things on the outside of space shuttles and space stations like the ISS. It is remotely operated and can do many multiple tasks, such as retrieving, repairing, and deploying satellites. Okay, Robonaut. Robonaut is a humanoid robot that consists of just the torso and arms. It has dual and dexterous workspaces, has plastic joints and extended fingers and thumb travel, along with force sensors and extreme neck travel and high-res camera and IR systems to complete all of its tasks.
So it basically can do what a human can, but better.
Yeah, it helps perform with tasks that would otherwise be very hard or impossible for humans to do. It's a great help in space exploration. It is also the first humanoid robot in space, although not the first created. And it has arms that can move at 2 meters per second, along with a maximum payload of 40 pounds.
And so we also have sent robots to other planets, like the moon, for example. Some of the first that were sent to the moon was the Ranger Impactor. So it was sent to the moon to just take pictures of the moon's surface as it went plummeting towards the moon. Then there's the Surveyor lander that was sent up to find feasible locations to land on the moon. And the Lunar Orbiter was sent up to also do the same as the Surveyor lander, but it did it in an orbit, so it found more locations. And during the Apollo missions, the command module and lunar lander were basically just robots because they had to provide life support for the humans inside, and it had sensors that were used to keep the navigation on track. And the lunar rover used directional gyros and odometer to navigate where the rover was going and where it came from. And we've also sent up robots to Mars. They've included orbiters, landers, and rovers. And we've had such an interest in Mars because it has the capability, might have the capability of supporting life. And a lot of them were in search for water on Mars. Well, guess what? We found it. So, orbiters and landers that were sent up. In 1964, the Mariner 3 and 4 were sent as the first flybys of Mars, so it flew past Mars, taking an image as it was going. Then in 1975, Viking 1 and 2 were sent up, and they were basically an orbiter and lander combined. And this allowed for the orbiter to give communication from the lander to Earth, and also the lander used biological experiments on the soil to determine the composition. And there's the Mars Global Survey in 1996, which was a quick replacement for the Mars Orbiter when that Mars Observer Orbiter, when that orbiter got lost. And it was also sent to survey Mars with high-resolution shots. And this was the first of high-resolution photographs of Mars. And then there was the Climate Orbiter in 1998, which studied the climate of Mars from its orbit. And then the Odyssey in 2001 used spectrometers and imagers to look for volcanic activity on Mars and also look for water. And that was also an orbiter. Then there's the Reconnaissance Orbiter, which is pictured up there, which acted to capture unique views of Mars from its orbit, and it's also used now as a communication link between some of the rovers on Mars. And there's the Phoenix lander that was launched in 2007, which was sent to look for microbial life on Mars. Some of the rovers that were sent to Mars was first...
I have a question.
Yes?
Did they all land? Oh, did they all complete the mission, or did some of them crash?
All of the ones that are in the presentation have completed their missions, and some of them have crashed over time, but it was just because their orbit decayed and they lost power and landed into the surface of the planet.
Skylab is an example.
Yeah, Skylab was in the 60s or 70s, I think.
Yeah.
And it fell into Australia
So
once the mission was completed.
some of those Mars rovers have been up there way longer than the mission intended them to be. We gained a ton of data from
Yeah.
just hanging around.
And like the reconnaissance orbiter is, its mission was completed. Now it's basically being used to communicate between the rovers and Earth. And so the first rovers were Pathfinder in 1996, which used a alpha particle X-ray spectrometer to find the composition of the soil was made up of. And then the Mars exploration rovers in 2003, it was sent up Spirit and Opportunity, which was to study the soil for signs of water on Mars. And just this year, Curiosity had landed on Mars, and its goal was to investigate the Martian geology and climate. And we're going to be pulling up here in a second the video of the landing maneuver that they used. They had to come up with a new one called the Sky Crane maneuver because of the size of Curiosity.
How hard is it to land Curiosity on Mars? On a scale from 1 to 10, landing on Mars is a 20. Curiosity is the biggest, most capable Mars rover yet, and needs a new type of landing to reach the ground safely. In this 7-minute trip to the surface of Mars, we had to slow down from over 13,000 miles an hour down to 0. Hundreds of things have to go just right. Curiosity must hit the atmosphere at just the right angle, endure extreme heat from friction as it descends through the atmosphere, open its parachute at just the right time, use radar to know exactly how high it is, free itself from the parachute, perfectly fire 8 rocket engines to slow final descent, drop down dangling on 4 cables, lock its wheels into place just before landing, and cut the cables right at the moment of touchdown. And even if we do everything right, Mars can always surprise us. It's a big challenge, but a big opportunity to help unlock the mysteries of Mars.
And so that Sky Crane maneuver was one of the most complex robotic maneuvers that man has ever done. And Curiosity was launched November of 2011. It took 8 months for it to reach Mars on August 2012. And some of the instruments that are used on Curiosity is the ChemCam, which uses a laser to vaporize rock layers in soil to find the elemental compositions of the rocks and soil. The MassCam takes high-resolution pictures of Curiosity's surroundings, and this contact tool down here is used to collect up soil that can be brought to the full chemical laboratory on the rover that uses a mass spectrometer, gas chromatograph, and tunable laser spectrometer, which all basically break up the soil into its compounds and elements to figure out what it's made out of. And it has a high-frequency antenna to send an X-band signal from Earth to Mars. And it uses some of the orbiters that are still up and around Mars, like the reconnaissance orbiter, to just strengthen the signals. Curiosity also has a weather station on it to find out what the weather is around the rover, and it uses a radioisotope thermal generator. So basically, it has nuclear power that will last for many years longer than Spirit and Opportunity. Curiosity also has a heat rejection system, which it pumps fluid through the rover to cool off the instruments when necessary, and it can gather excess heat from the generator and disperse of it. And some of the it has extra batteries on there to just for safety, and they have a thermoelectric coolers and heaters to keep it at the right temperature. And the software on Curiosity, because the landing was so complex, they needed different software for landing and for roving around. So the landing sequence had one program that ran it, and then they had to upload new a new program for driving it around Mars, and the software continually updates to get out any bugs and add new information, and it runs fully autonomous. And then there's Dawn, which is a probe that was sent to two large asteroids, Ceres and Vesta. It has already reached and passed Vesta, which is the picture on the top right, and it will get to Ceres around 2015. The framing camera that's on Dawn is used to navigate the probe through space, and it's also used to take pictures of its surroundings like Vesta. And it uses a gamma ray and neutron detector to measure the abundance of major elements like potassium, iron, water, magnesium.
Now, is either asteroid a threat to Earth?
Not as of right now. They're in the asteroid belt, I believe, so they're pretty far away from Earth.
So why pick those two?
Because there are two different types of large asteroids. One is dry and one is wet. So they're just picking them out to see what the material is like on the asteroid.
So, the Cassini-Huygens is a robotic ship sent to Saturn to study multiple aspects of it, including its rings, ice satellites, and magnetic sphere Titan, one of its moons. Huygens was dropped onto Cassini and took first pictures from the surface of Titan. The whole project started in 1998, where it flew by Venus, and as of now, 2012, it has been measuring signs of high-altitude haze and vortex forming at Titan's south pole. Okay, so Voyager and Pioneer. Pioneer 10, to be precise, is a 258-kilogram robotic space probe that is meant to study Jupiter. It was the first to reach velocity and leave escape velocity, and leave the solar system. Voyager 1, on the other hand, is the most distant functioning space probe. 17.
It moves at 17 kilometers per second.
On December 3rd, 2012, Voyager discovered an unknown region of the heliosphere, which was influenced by the sun.
The heliosphere is basically where the sun has an influence on the pole of where anything is traveling, and there's also a picture of Voyager there.
It is also expected to leave the last barrier of the solar system between 2012 and 2015. For future robotics in space, there's New Horizon, which will be sent to study Pluto and its moons in 2015.
It has already been sent out, so it's kind of recent.
And there's also the Europa Jupiter Systems mission, EJSM for short, which will be sent to the moon Europa to drill for ice and signs of life.
So we're hoping that you would get out of this that robots are seen everywhere, and we couldn't have done nearly any of this exploration space without them. They're a lot cheaper and more efficient than sending humans up because they don't need the living conditions that humans need. And they also can last better in more extreme temperatures of space, like the heat of Mercury or the cold of Pluto. And so we hope you found out a little bit more about information of how robots have paved the way for space exploration. Any questions?
That's great. Thank you.
We can do it both.
Actually, I have one last question. You said that one of the satellites was going to leave orbit or leave the solar system?
Yeah.
Are we
Voyager.
going to lose contact though?
No, the signal will still be able to be sent back to Earth from Voyager. It takes, I believe, 7 days to send the signal to and from Voyager.
That's totally out of propellant. It's just coasting at this point.
Yeah.
Awesome. Thank you very much.
Thank you.